Bismillahirrahmanirrahim. Assalamu alaikum. Today, inshallah, we will study how assembler works and what is meant by one pass assembler and two pass assembler and how two pass assembler works. Basically, our target is to study two pass assembly. Yes, better. We have studied that we have two different types of languages, high level language and low level language. And in low level languages, we have further two types. One is known as machine language that is directly understandable by computer and other one is known as assembly language. Right, beta? So today we will study how assembly language code is converted into machine language so as computer can understand it. We know that computer's own language consists of 0 and 1 and assembly language consists of mnemonics. The mnemonics are the assembly language codes. For example, we are using LDD101. Here LDD101 means if we are using a command LDD101. Here LDD101, this part of the command is known as opcode while this is known as operand. Sometimes we use this type of operand, sometimes we use LDD value. So we say that this type of operand is not mentioning what are the memory location to store data from there, and this is showing that with what is the memory location from where we are asked to load the data. So we say that this is absolute address, while this is known as symbolic address. Before studying further, we should study how assembler works. We have studied that assembler, whenever we write down a command in a program in assembly language source code is sent to assembler. Assembler scans whole code for error, and if there and check that is there an error. If an error is found, then assembler produce error report after scanning whole the code. At the end of the scanning whole code, it produce error report after scanning whole code. Then this programmer use code editor to correct this error, and then again this code is produced, and then this code is sent to assembler. Assembler again scan whole code for error. If there is an error, then again this process is done. If there is no error, right, then this code is translated into machine code, right? If there is no error, then translation is done into machine code. The machine code is known as object code. Then it is saved as executable file. Today we will study the steps of converting a source code into object code. To convert a source code into object code, firstly we have studied that in our source code basically we have the opcode and operand. Each opcode has its equivalent binary code. Like here you may see that our opcode have like here LDM. Huh? The binary code of LDM is 1100000001. The binary code of LDD is 11000010. So when we are asked to translate the source code, if there is no error, then LDD is replaced with 11000010. Wherever we have LDM, it is replaced with 11000001. But problem is that sometimes we have symbolic addresses. If we have symbolic addresses like here, like here. It says that LDV, so we can convert LDV into binary. The binary of LDV is 11000011000011. But then there is countdown. Huh? We cannot convert countdown into binary. On the other hand, in some programming languages, we write down the commands in this way, like LDD 100. So what will we do? We will translate LDD into binary, and then 100 will be translated into binary. 100 is the memory address. So we can translate this 100 into binary like 1, 2, 4, 8, 16, 32, 64, 128, and 1248. So we have translated this code into object code. Right, beta? This type of address is known as absolute address. But sometimes we write down assembly language code where we don't use absolute address, we use symbolic addresses like here. Here, right? For that, what we need to do, we need to maintain a symbol table. In the symbol table, we write down all symbolic addresses and then we write down their actual addresses, right? For example, so for that we use these steps. Yes, beta. Firstly, we remove the comments. Then we create a symbolic table, a symbol table containing the binary code for symbolic names and labels. These are like countdown or something. These are also known as labels. Creation of literal table if the program has used in constant. Expansion of macros, whatever the macros is given. Macros means collection of codes are written, statements are written, and identification of the system call and subroutine. So here, for example, this is our program in which we have used symbolic addresses. So in this program, this is known as directive. Directive tells how to some directive has some instruction for the assembler. This directive says that origin of the program is from 01100. It means the address of this, right? This is the start program, so its address will be 100. So start program is a label, a symbolic address, and this address has an absolute address that is 100. So we write down start program and 100. We have studied when we start reading the code. Firstly, we reach at this location means the this label is scanned at first. Huh? So we have written 1 over there. Then we have read the location of this is 2. Then we find another symbolic address that is countdown. So we note down the countdown. It occurs at third number. Then num1. So we write down num1. Acha, the address of start program is 100. So we have noted 100, right? But the address of countdown is not known. We have studied, we have read only first statement. Now we don't know the address, actual address of the countdown. So we write down that this is unknown. Then we read the next symbolic address num1. We have recorded it in symbol table, and then we record it as unknown. Then we find another symbolic address, carry on, we write it down, and this is also unknown. Then we find another symbolic address, finish, we note it down, and unknown. Then we have we read carry on, and carry on was found at location 104. So now we know the address of carry on. So here is the carry on. So what will we do? We will erase unknown and we note down the absolute address of carry on, and it occurs at 11th location. Means after its turn was 11th. Then countdown, we have studied it. Countdown, start program. Now we find finish. So and its address is 109. So here is finish and its address we note down 109. Then we find countdown. So we note down the countdown's actual address, that is 112. And then num1, we note down the actual address and num1, that is 116. Now we know all the addresses, absolute addresses of all symbolic addresses. Then what we do, we replace all symbolic addresses, all symbolic addresses with the absolute addresses. It means here it will be written as LDV, LDV countdown. What is the address of countdown? 112. CMP num1. What is the actual address? 116. JNE carry on. What is the actual address of carry on? Is 114. 104. Then out character. Then LDD countdown. LDD countdown. The actual address of countdown is 112. And then decrement the countdown. Then store at location countdown means 112. So we replace all symbolic addresses with the absolute address. After replacing all symbolic addresses into absolute address, then we start translating these into machine language. For example, we have a program here. Here it is written, if we have this program in assembly language, then what we need to do, we need to, at the translation stage, firstly we will translate LDD into binary and then 100 into binary, CMP into binary and 104, JPE and 54, LDX and 100. But if we have this program, so what we need to do, we need to maintain a symbolic table, right? Suppose here we have the, hmm, yes beta, now it said that the program is starting at location number 100. It means its address is 100. So we write down 101, 102, 103, 104, 105, 106, 107, 108, 9, 10, 11, 12, 13, 14, 15, and 16. Now Start program was found at first occurrence, so we have noted down as 1, and its address is 100, so we have written 2. Basically, these in circle 1, 2, 3, 4 are basically their sequence of entry in the symbol table. In the symbol table, firstly we have entered start program, then we have entered 100, then we start reading, so we find countdown, so we noted down countdown and its entry number is 3, and we don't know the address of countdown until we have studied whole the code. In the first pass we will study whole the code, and we will find the actual address, right? Absolute address. So we have noted down 3, and its address is unknown, and its entry number is 4. Then num1 entry number is 5, and this is unknown. Entry number 6 carry on, entry number 7 unknown, entry number 8 finish, entry number 9 unknown, entry number 10. Then we find carry on. So we go to carry on and we note down its absolute address 104, its entry number is 11. Then LDD countdown, we have entered countdown, countdown, start program, L finish. Now we find finish, so this is finish, and its actual address is 109, and its entry is 12. Right, बच्चों? Then out character and countdown. Now we find countdown at location 112, and its entry number is 13. Then num1. Num1 is found at location number 116, and its entry number is 14. सही है बच्चों? So this is the way. Acha, when we find the address of countdown, and then we find the address of unknown, so we will cut it down, and then this one and this. So in the first pass, what we have done, we have replaced all the symbolic addresses with the absolute address. After replacing symbolic addresses uh, with absolute address, then in the second pass we start its translation into machine code or object code. So in the first pass, what we do, we remove all the comments, we remove all the white spaces, we expand macros, and then we uh, replace all the symbolic addresses with the absolute address, and in the second part we perform translation, right? So you may be asked to write down the steps, explain how the assembler made these entries to the symbolic table. So what you will write down, assembler will start reading each statement. uh, Whenever it finds an symbolic it find a symbolic address, it no enter this address in symbol table, and when it find another symbolic address, then it is entered. But if a symbolic address is found, like countdown is found over here, and again it is there, so as it is already entered in the symbolic table, so you don't need to enter it again. It will not be entered again. It will entered only once, like here countdown is found, it is already stored over there, so you don't need to enter it again. Start program you have already entered, so you don't need to enter it again. But when you find the absolute address of a symbolic address, this absolute address will be noted down in the address, like here we have done. ठीक है बच्चों? So you need to write down these steps. I will show you the steps which are given in the yes here. The assembler scans the assembly language instruction in sequence. When it meets a symbolic address, checks to see if it is already entered in the symbol table. If not, it adds to the symbol table in the symbolic address column. If it is already in symbol table, if table checks if absolute address is known. If the absolute address is known, then it is entered in the appropriate cell. If the absolute address is not known, it is marked as unknown. Like here we have done unknown, unknown. Now its address is known, so you will cut it down and you will enter it. For example, we have another question. Acha, in this question, you are asked to write down the steps. Right now in another question we are asked to uh, complete the symbolic table. Like here, this is the symbolic table and you are asked to complete this symbol table. Part of the symbol table is complete and we will, yes beta, it says that start program is entered at first and its address is 0. It means we will note down this as 0. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we can say that this is not actual address, this is relative address, right? Acha, bhai. Now LDV offset. So we entered offset at its entry is third and it is unknown. Then compare with values, we enter value and 5 and it is also unknown. And its entry number 6. And then end program, so we will write down end program, its entry number 7 and it is also unknown, right? Then LDD offset we have already entered, so we will ignore LDD offset. Start program we have already. Now we find the relative address of end program. We say that this is relative address because actual address is not given, as it has mentioned that start program is 0, so we have written at it as a relative address. So offset. So the the end program's actual address is 8. So we will cross it. We write down its entry was 8. We have crossed it and its actual address is 8 and its entry number is 9. Then we find offset. Offsets now. Offset's address is 9 and its entry number is 10. Then we find value. So now we know the value and its address is 14 and its entry number is 11. Right, beta? And then, yes, ADD 90. This is absolute address. Compare found. Found is symbolic address 20. 20 is absolute address. Now, creation of create table first pass, expansion of macro first pass, generation of object code will be second pass, removal of comment is first pass. Okay, bachcho, that's all about this. See you next time, inshallah.